The James Webb Space Telescope, in a groundbreaking discovery, has detected and studied the most distant active supermassive black hole known to date. This remarkable finding unveils a galaxy called CEERS 1019, which came into existence just over 570 million years after the Big Bang. What sets this black hole apart from others in the early universe is its relatively modest mass, weighing in at around 9 million times that of our Sun. In comparison to its more massive counterparts, which have been detected by previous telescopes, CEERS 1019's black hole is significantly less luminous. The larger black holes, often containing over 1 billion times the mass of the Sun, are relatively easier to detect due to their brighter emission. These behemoths actively consume matter, causing it to emit light as it swirls toward the black hole. On the other hand, CEERS 1019's black hole shares similarities with the one residing at the center of our Milky Way galaxy, which has a mass of approximately 4.6 million times that of the Sun. However, even though it is smaller, CEERS 1019's black hole formed so early in the universe's history that the exact mechanisms behind its creation remain challenging to explain. While smaller black holes were expected to exist in the early universe, it was only through Webb's observations that definitive detections could be made. It is worth noting that the claim of CEERS 1019 holding this record may be subject to change, as other more distant black holes identified by Webb are currently undergoing careful review within the astronomical community. The wealth of data collected by the Webb telescope is brimming with precise information that enables such confirmations to be extracted effortlessly. Rebecca Larson of the University of Texas at Austin, who led the discovery, emphasizes the similarities between analyzing this distant object and scrutinizing data from black holes in galaxies near our own. The abundance of spectral lines allows researchers to untangle emissions from both the black hole and its host galaxy, providing insights into the amount of gas being ingested by the black hole and the star formation rate of its galaxy. The findings of the CEERS survey extend beyond CEERS 1019, encompassing additional remarkable discoveries. Within the dataset, the team swiftly identified another pair of smaller black holes. The first, located in galaxy CEERS 2782, was readily discernible due to the absence of obscuring dust, allowing researchers to determine that its black hole existed just 1.1 billion years after the Big Bang. The second black hole, situated in galaxy CEERS 746, appeared slightly earlier, at 1 billion years after the Big Bang. The bright accretion disk surrounding this black hole, consisting of gas and dust, is partially veiled by dust clouds. Dale Kosevsky of Colby College suggests that the presence of dust might indicate a galaxy intensely engaged in star formation, potentially fueling the activity within its black hole. Similar to CEERS 1019, these two black holes are also considered lightweight when compared to previously known supermassive black holes at such vast distances, with masses approximately 10 million times that of the Sun. Webb's capability to capture these elusive objects so clearly opens up the possibility that lower-mass black holes could be widespread, waiting to be discovered. Prior to Webb's observations, all three black holes were too faint to be detected, appearing as ordinary star-forming galaxies when observed through other telescopes. The high-resolution spectra obtained by Webb also allow researchers to measure precise distances and determine the ages of galaxies in the early universe. For instance, the team identified 11 galaxies that existed between 470 and 675 million years after the Big Bang. Notably, these galaxies are rapidly producing stars but have not yet accumulated the same level of chemical enrichment as galaxies closer to our own. The identification of numerous bright galaxies at such extreme distances is an intriguing surprise, challenging previous theoretical expectations that suggested fewer galaxies would be detected at these cosmic epochs. The CEERS survey represents just the tip of the iceberg in terms of the groundbreaking scientific insights that Webb will provide. Prior to its launch, much of the research on objects in the early universe was largely theoretical, but now, with Webb's observational capabilities, the ability to accurately measure and study black holes and galaxies at extreme distances becomes a reality. This telescope holds tremendous power in reshaping our understanding of black hole formation, revision of models detailing the growth and evolution of black holes in the first few 100 million years of the universe's history. The findings from the CEERS survey have resulted in several accepted papers by the astrophysical journal Letters, shedding light on topics such as the discovery of an accreting supermassive black hole 570 million years after the Big Bang, spectroscopic identification of low mass, broad-line active galactic nuclei, and the confirmation of CEERS NIR CAM selected galaxies and their properties. The James Webb Space Telescope, a joint effort led by NASA in collaboration with the European Space Agency, ESA, and the Canadian Space Agency, CSA, stands as the world's premier space science observatory. With its ability to unravel mysteries within our solar system, explore distant exoplanets, and probe the enigmatic structures and origins of the universe, Webb holds immense potential for transforming our understanding of the cosmos and our place within it. Thanks for watching. Don't forget to like, share and subscribe for more interesting content.